In 2020, I was the first YouTuber to make a video about Meshtastic, created by Kevin Hester. The project name was a merge between Mesh and Fantastic. Already then, I loved the project. But why is it the most dangerous LoRa project? Here is the proof. My video was included in a study titled Network-Enabled Anarchy by an organization featured by the US government under the topic Instructions for Encrypted Messaging. So stay tuned when I show you what you can do with it, even if your profession is not terrorist. Gritty YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. My video was mentioned in the same sentence as 3D printed weapons. Why? Because Meshtastic creates encrypted LoRa mesh networks independent of any mobile infrastructure, hard to detect and hard to observe. But if you do not plan to become a terrorist, what's in for you? First, mesh networks are fun to play with. Plus, because of LoRa, they have a good range. And third, the project evolved and can now be used with repeaters, with tunnels across the internet, and to transfer sensor data. And it supports a wide variety of devices. All exciting stuff. Instead of explaining how it works, we build a small network. I use 3 different devices. A simple TTGO LoRa board connected to USB power, a TTGO T-beam with battery and GPS, and a newer T-Echo with an nRF52 chip and an e-paper display instead of an OLED. This results in a very low power consumption. It also contains a battery and GPS. First, we have to flash the Meshtastic software to all devices. Fortunately, this is very easy. If your board is based on an ESP32, go to this website, select your device and the requested firmware version, and wipe and reinstall the device. If you connect your device with a USB connector to the computer, you can select the proper COM port, hit connect and install. After a few minutes, our 2 ESP32 devices are ready. The T-Echo is programmed in 2 steps described on the Meshtastic page. Erase the memory and program the new firmware by dragging 2 files to the USB drive created by the T-Echo. Done. The programmed Meshtastic devices can connect to a PC or Mac and to iPhones or Androids. A tip I learned the hard way. Use a different smartphone for each of your Meshtastic nodes. Otherwise, it is easy to lose the overview. In this video, I connect the LoRa board to the PC because it anyway requires USB power and will later have a special function. The T-beam is connected to the iPhone and the T-Echo to the Android. Like that, I always know where to change settings and send messages. Before connecting our smartphones to our devices, we must install the Meshtastic app. You can find them in the respective app stores. For the LoRa board connected to the PC, I use the web client hosted by the project team. It connects the LoRa board via the serial connection. Cool! The T-Echo and the T-beam must be paired to the respective smartphone by entering a 6-digit number. Sometimes it does not work the first time. Be patient and switch the Meshtastic node off and on to start over. The device gets a name based on its MAC address. This name is essential because it appears on all messages. As a first step, you have to select the region. Because I have 433 MHz boards and I live in Europe, I choose EU 433. You must check the allowed frequencies in your country before ordering your LoRa devices. Their frequency range is fixed. Sometimes you get devices with preloaded Meshtastic software. Because the project moves fast, I would reprogram it with the newest firmware before starting. This cloud with a tick mark shows if your phone is connected, by the way. Now we can go to settings to choose what we need. A tip if you do not know how to navigate the Android app. A left sweep is the back function. It took me a while to find it. The app on the iPhone looks different, but it has the same functionality. And an arrow for back. Now we are ready to rumble. Our smartphones should show 3 notes, and you should know their names. This is because Meshtastic selected a default combination that works out of the box. We can start to exchange messages between the 2 smartphones. And no, the smartphones do not need to be connected to any network. You can turn off mobile data and Wi-Fi if you want to prove that Meshtastic only uses the built-in LoRa transceivers. Just keep Bluetooth enabled. You can send a message to all or only to one device, and if successful, get a tick mark in the cloud. This is possible because we use the primary channel and the long-fast profile. The profile is used to tweak the radio settings. Long-fast is a good compromise between range and transmission speeds. They offer other profiles if you want to play. The different channels can be used to create privacy. Frustration can occur if your radios do not have the same settings. This is why Meshtastic introduced a QR code that distributes all channel information between your nodes. I highly recommend using this method. Because my LoRa board connected to my PC has no camera, I create the QR code there and use the smartphone cameras to transfer the channel info to the other 2 nodes. So we created a mesh network with 3 nodes. What is the typical range of such a network? As a rule of thumb, LoRa works very well if there is a line of sight between 2 nodes. In video 120, I could bridge 203 kilometers with similar modules. I also show how to simulate the ranges of a particular node. And I regularly get messages from small LoRa satellites 2,000 kilometers away. You also find videos on how to build performing antennas on this channel, by the way, even by using a Harley-Davidson for the job. But LoRa does not work very well if there is no line of sight. With meshes, the chance to get a line of sight between 2 nodes becomes bigger with a number of mesh nodes. And of course, if we place at least 1 node on a hill or a tall building, the chance for a line of sight connection increases a lot. But more about that later in the video. What if we want to connect to our buddy in a different town? No problem. Meshtastic provides a free MQTT server on the internet to connect all users of Meshtastic. But how can we connect to this server? We have to connect to the internet, of course. But if our board uses Bluetooth, it cannot connect to the internet with Wi-Fi. And the nRF52 does not offer Wi-Fi at all. Fortunately, the project team had a marvelous idea. If you enable MQTT client proxy in the MQTT menu, your Meshtastic node uses the internet connection of your smartphone. Very clever. As soon as you enable MQTT and the client proxy, as well as up and down link on the channel, you should see messages coming from unknown sources, and you should see many new nodes. This is possible because the default credentials of the MQTT server are already populated. SEQ messages with a number are spam, by the way. They are range test messages of people who do not know what they do. On the iPhone app, you can flip a switch to mask them out. I do not know if this feature already exists on Android. Now you can start messaging with a stranger, or if you find your friend, start a conversation with him. Of course, this method depends on the internet and is unsuitable for emergencies. But still, it is handy and fun. For more privacy, you could create your own MQTT server and connect your meshes to this server. I promised that we would talk about nodes placed at a good location. Meshtastic offers a particular role for such nodes: router or its simpler sibling, repeater. Because of their excellent position, they are preferred for message transfers. They usually are not used to creating or reading messages. This fits perfectly with our LoRa board without batteries and without a smartphone connection. It becomes our router and extends the range of our mesh without internet access. Adding solar panels to such a node can run it for at least the whole summer without attention, and it can serve a wide geographical area. If you have internet access at the router on the hill or the tall building, you can enable MQTT there and connect your entire mesh to an MQTT server. An extremely useful function because none of the other nodes or smartphones need internet access. If you do not want to use your smartphone, you can buy or build a standalone device with a display and a keyboard. The last feature I will mention is the possibility of attaching sensors to a node. This greatly extends the options because you can place sensors everywhere, even if the hub has no line of sight to all nodes. Other mesh nodes then automatically relay messages from invisible nodes. And as a last resort, you can place a router or repeater in a good place. The sensor nodes, of course, do not need a smartphone and therefore are cheap. Our T-Beam and T-Echo have a built-in GPS sensor, so they can transfer our position if we want. And if your node has no GPS, you can use the one of your smartphone. Again, clever programming. And finally, you can connect Node-RED to the MQTT broker and get the sensor readings for automation and reporting. So, we were able to create a mesh network consisting of 3 nodes. The typical range of such networks is enormous if there is a line of sight between nodes, but only small if not. We tried 2 ways of extending the range of our mesh. With a router or repeater on a hill or tall building, we can significantly improve the range of our mesh without connecting to infrastructure. By linking to an MQTT server on the internet, we can extend the range to the whole world. If we connect sensors to nodes, we can create a mesh of sensors. The most prominent sensor is GPS, which shows you the position of your bodies. If you use the Node-RED integration, you can use the sensor readings in your automation or reporting. I did not cover the so-called CLI interface. It is particularly useful for provisioning sensor nodes. It is no wonder that this project is widely used and even preloaded on some Chinese boards. One last thing. If you build your Meshtastic node, we will meet on channel 5 on the MQTT server. Just mention my name in your message. This was all for today. As always, you find all the relevant links in the description. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. Thank you. Bye.